Okay, now that our pathogen has obtained nutrients, it's gone from maybe 5, 10 cells, and now it is thousands, tens of thousands, millions. Or if it's a virus, it's tons and tons of virions. When you get to be that many, it's hard for the immune system not to notice. So now we have to figure out how to get around the host's immune system. This is evasion. So you'll see in figure table 10.6, there are two basic approaches that pathogens will take. The first is hiding. Not a very elegant thing to do, but it works. And in hiding, you can take three different forms. So figure 10.8 gives examples of antigen masking, antigen mimicry, and antigen variation. So antigen masking. This is a very simple way to hide. This is essentially the wolf in sheep's clothing. This is what those envelope viruses are doing. Remember, they took your plasma membrane and put it over themselves, and so now they can go walking around because they look like you. They don't have to, they're sort of hiding in plain sight. It's like a Trojan horse would be another example. So antigen masking is when you take something from the environment, something from your host, put it on you so that then you can hide within it. Same thing like when they were using that coagulase, hiding inside a clot. Another good way, basically, of hiding. Another form of hiding is antigen mimicry. This is not taking something from the host. You have genes that produce something similar to what the host does. So you go into your host, or you sit extracellularly on your host, and you make something from your own genes, and then you put it on. So you can see in the example here, the host cells know how to make blue hats. The pathogen also knows how to make a blue hat. So the pathogen will make its own blue hat and then wear it, and that will allow it to hide from the immune system. And then antigen variation is sort of a combination of these two. You keep changing your disguise. This is what the flu does. Every year we have to get a new flu shot because they've changed those spikes in that envelope enough that it looks like something different to your system. So antigen variation is just what that name implies. You keep changing, varying the disguise you're on so that as soon as the immune system figures out one disguise, you put on the second disguise. As soon as it figures out the second disguise, you go find it. This may come from something that you make yourself, or it may come from something you bring from the environment. Another way of hiding is latency. So this is a term we saw with latent persistent infections. This is when you sort of go into a cell or can find your way to find yourself a permanent hiding place, and you sit in low numbers, and when you're at low numbers, the immune system can't really find you. Plus, you're not moving around. But then if you notice that you have good conditions, you can then all of a sudden come back out of your hiding spot, proliferate, cause your damage again, and then you can just go hide back in the system. This is what mono does. If you've ever had mono, you've never gotten rid of it. It will come, your body will fight it off, it'll fight it down to a low number, and then it goes and hides in the body. When conditions change and you get sick again, it goes, hey, I think I can take advantage of this, comes out of hiding and comes back after you. So latency is when you hide. This is when you have those latent persistent infections because they come and go depending on your condition. And then thirdly is intracellular lifestyle. There's no better way to hide from the immune system than to be in a cell of the host, because the cells of the immune system don't go into your other cells. They just patrol the outside. So if you go into a cell, remember that's one of the ways that you can invade, you're also automatically evading the host's immune system because you have set up shop in a house and it doesn't come into your house. So those are the ways that we can hide. The other set of approaches are called undermining. And there are lots of ways that you can undermine the host's immune system. These, you notice, are broken up into two big groups. One of these groups is called suppress. The other big group is called avoid phagocytosis. So if you need to, go back to chapter 4 and review how phagocytosis occurs, because you're going to see it again. So first, suppressing the immune system. We'll talk about this more in chapter 12, but you can break down antibodies. Antibodies are patrols that come looking for you. So if you kill the police officer that's trying to look for you, it's going to be very hard for them to come after you. You can infect the immune system cells. If you make the cells that are trying to harm you sick, then they can't do your job and affect you. You can also block communication. This is something we do in our own warfare. We know that if we can take out communication satellites, you can't communicate with your troops. You can't communicate with your troops. Your troops don't know what to do. They are in chaos. Or you can inhibit production. This one is literally suppression. If you can stop the building of cells of the immune system, then there's going to be no one out there to patrol for you. All right, the last part, avoiding phagocytosis. This is in figure 10.9. So, quick review. In phagocytosis, a pathogen will be engulfed. That new vesicle inside the immune system cell is called a phagosome. The phagosome will then merge with the lysosome, which has hydrolytic enzymes called lysozyme. These will break down, so when they merge, you get a phagolysosome, and then the lysozyme will break down the pathogen and you will eliminate it. So that's your defense. Phagocytize the pathogen, break it up. There are lots of different ways, though, that you can avoid this. So you can see that there are 5 different ways discussed in the figure. So the first one, I'm going to have to put these to the side. You can definitely avoid phagocytosis if you yourself, as the pathogen, produce a toxin that kills that cell and breaks it down. In a sense, this is almost a way of basically infecting immune cells. 2, I'm going to go to the right. You can have a capsule that doesn't allow you to be captured. So sometimes capsules can be very good because they allow you to adhere. In this case, you don't want to adhere. You want to actually be able to escape. If you have that slimy glycocalyx, that slimy S layer, it's like having a greased pig. And if you try to pick up a greased pig, it squirts right out of you. Same thing here. You have cellular component, this capsule that is made of things that are basically slippery, not allowing you to be caught by the immune cell. 3, you can block fusion. So you can see in the left-hand column, the second one down, if the enzymes are in the lysosome and you're in the phagosome and you never become a phagolysosome, then enzyme that can break you down won't be able to break you down. So you send out different chemicals that block this fusion, and therefore you yourself never get broken down. Or you can escape the phagosome. Once again, if you escape the phagosome, then even if it does merge, the lysosome does merge, it's now going to merge with an empty cell, and that lysozyme has nothing to break down. Or lastly, you can just learn to live. in a harsh environment. You, the pathogen, get phagocytized and get engulfed into a phagosome. It merges with that lysosome. You can even see the hydrolytic enzymes, the lysozyme, surrounding that pathogen. But you, the pathogen, produce something that will block, inhibit those enzymes and not allow them to break you down. So avoiding phagocytosis can take 5 different ways. So these are the different ways, different approaches that you can evade the host immune system. This is a good intro. Chapter 11 and Chapter 12 is going to go into much more detail on the different types of defenses you have in order to get these pathogens.